We are starting chapter 9, and this is lesson 3 where we're talking about radicals, and another word for that is like a root, a square root. I can have a square root, a cube root, things like that. So, our goal today is to simplify radical expressions. And these are things that are going to be under a square root. So, radical is an expression written with a radical symbol. You'll be drawing a lot of those, so get used to what that looks like and practice drawing some. So, a radical, I'm putting this at the top of your paper. Ready? A radical is like prison. Okay? You can only get out. You can only get out if it's the number, or variable. So a radical is like prison. You can only get out if it's a perfect square. Okay, so perfect squares. I had you already write it, but I'm going to write it right now. Like the square root of, the square root of 1 is 1, but we don't really, everyone knows that. The square root of 4 equals 2. The square root of 9 equals 3. The square root of 16 equals 4. The square root of 25 equals 5. The square root of 36 equals 6. The square root of 49 equals 7. The square root of 64 equals 8. The square root of 81 equals 9. The square root of 100 equals 10. The square root of 121 equals 11. The square root of 144 equals 12. We've already taken a quiz on this. It comes up again and again. So, in the journal section, product property of radicals. If I have two numbers underneath the radical, like a times b, any number, I can separate them out and make it the square root of a times the square root of b. Where a is greater than 0, which is a positive number, and b is greater than 0, positive number. And since we're talking about 0, the square root of 0 is 0. You just can't do it. We don't do square root of 0. I'm never going to put that as a question for you. The square root of 0. No, we actually just have positive numbers under there. So, the square root of like a 4 times 5. We know that that's 20. But I had to break it down into a perfect square. 4 is a perfect square. That would be the square root of 4. Let's separate it. The square root of 4 times the square root of 5. Separate it out. Well, you guys, here's a perfect square. What is the square root of 4? 2. So I'm going to get 2 on the outside, not inside the perfect square anymore. But what about the radical 5? Is that a perfect square? No, I can't do a thing with it. I have to leave it as radical 5. My answer is 2 radical 5. And I could say 2 times the square root of 5. I can say 2 rad 5. I can say 2 radical 5. That's how I would pronounce it. Quotient would be just a division. Same thing. If I have a fraction inside, I could do the square root of A over the square root of B. A is going to be positive, greater than 0, and B is going to be positive. Okay, what about square root of 9 and square root of 25? Separate it. The square root of 9 divided by the square root of 25. Are those perfect squares? They're great numbers. They're easy. So what's the square root of 9? 3. Put a 3 in your numerator. What's the square root of 5? I'm sorry. Anyways, just it's a 5 in the denominator. Is this easy stuff for you guys? Okay, 50. You guys, you must think of a perfect square. So when I say, you guys, what makes 50? I do not want you to say 10 times 5. That's not okay with me. 10 times 5 is not okay because 10 is not a perfect square and 5 is not a perfect square. I'm going to break down 50 into something smaller. I'm going to break it down. And I have to use a perfect square. Tell me a factor is a small number. Tell me a factor of 50 that's a perfect square. Look at this list. 4, 9, 16, 25, 36, 49, 64. Are any of these numbers that go into 50? 25? So I'm going to split 50 up into, put the perfect square first. The square root of 25 times the square root of 2. I don't need to make that so long, sorry. The square root of 25 times the square root of 2. Put the perfect square first. Okay. What is the square root of 25? 5. Can I do anything with the radical 2? Can I simplify that? No. So here's what I'm going to get. The 25 comes out as just a 5. And then it's radical 2. Still inside. Okay. Let's do B. 48. Think of a perfect square that goes into 48. Look at your list on the side of your paper. What goes into 48? 4. 4 does. 4 times what? 3. Not 4 times 3. 4 times what? 12. Okay. Well, what's the square root of 4, you guys? 2. Out of the square root symbol. 12. Is there a perfect square in 12? Think about it. Not 6, not 3. That's not on my list. 4, 9, 16, 25, 36. 4. Doesn't 4 go into 12? So I actually have to go another and break down 12. 4 times 3. I don't need to separate the 4 and 3 if you don't want. Because what's the square root of 4? 2. So now I have, look at this slowly. I have the square root of 4 was 2. This square root of 4 was 2. So I have a 2 times a 2 on the outside. What do I do with the rad 3? Can I break it down? No. Rad 3 stays rad 3. but I multiply those numbers that are on the outside there. So 2 times 2 is 4 rad 3. Can I tell you something about 48? There's another perfect square that goes into it. 16. So what took me so long? Look at all these steps I had to do. I could have just done 16 times 3 and would have become 4 rad 3. But I had to know that 16 times 3 was 48. And sometimes you don't know that. And if you don't know it right away, then you got to go little bit by little bit slower. So think of the perfect square that goes into these numbers. Well, look, I just did 12 right here. I already did that one. Square root of 4 times 3. The 4 comes out, 2. The rad 3 stays in. The 4 comes out as a 2. Square root of 4 is 2. And the rad 3 stays. All right. What about 32? Number 2. What about 32? 16 times what? 16 times 2. Do you guys want me to separate them or do you want me to keep them under 1? Okay. 16 times 2. Way too cramped in there. Take out the perfect square. The 16 is the perfect square. Square root of 16 is what? 4. So that comes out as a 4. But what about the radical 2? Stays. I can't do a thing with it. 4 rad 2. Okay. Do 75 with the people at your table. Think of a perfect square that goes into 75. Tell the people at your table. 75. All right, tell me out loud. What'd you say? 25 times 3? 25 comes out. 5, but the radical 3 has to stay in. 5 radical 3. Okay. 180. Woo! Four, 9, 16, 25, 36, 49. What's the number that goes into 180? 180 is big. All right, take out the 0. What goes into 18? 9. So if 9 goes into 18, don't you think 9 is going to go into 180? 180? That's how math works. It will go in. So I'm going to do 9 times what, though? Write the square root first. 20, because 9 times 2 is 18. So just add a 0. Okay. 9 times 20. The 9 well, you guys, I can break down 20. Let me go over here. 20 is what? What's a perfect square that goes into 20? 4, 9. Do they go into 20? Which one of those? 4 does. So 20 is 4 times 5. 9 times 4 times 5. 9 times 4 times 5. And so I take out the perfect squares. 9 is a perfect square. I take it out. What does it become? Becomes 3. 4 is a perfect square. What does it come out and become? 2. This is going to be 3 times 2. What do I do with the 5? Stays in. I only can take out a perfect square. What's 3 times 2? 6. Rad 5 is my answer. Now I have a fraction. No problem. Do the numerator and then do the denominator. 32 is what? We did 32 up above. What's 32? It's right here. 16 times 2. Okay. Denominator, 50. What's 50? 25 times 2. Okay, so write that down because I kind of went fast. You can take out a perfect square. What perfect square? I want new volunteers. So if you've already helped, take a break. Stay quiet. What's a perfect square in the numerator? Is it 16 or is it 2? 16. What does 16 come out as? 16 comes out as 4. 4. What do I do with the 2 that's still there? Stays. Someone said stays. Okay, 4 root 2. What's 50? Which one of them is a perfect square? Is it 25 or is it 2? Is anybody going to help her? She's just going to do all this herself. 25 comes out as? What do I do with the root 2? Okay. So far, so good. By the way, what happens when I have the same thing over itself? Something over itself. 8 over 8. 10 over 10. Z over Z. J over J. Rad 2 over rad 2. Aren't they 1? So I don't have to include that. My answer, it cancels out because it becomes just like 1. My answer is 4/5. Okay, break apart number 2. Rad 4, numerator. Rad 9, denominator. Rad 4, numerator. Rad 9, denominator. What's the answer? They both are perfect squares. 2/3. Good job. All right. 5 times, the 5 in front means times, rad 1 over rad 25. Split apart. Numerator, rad 1. Denominator, rad 25. A number in front means multiply. 5 times that. Okay. What's the square root of 1? This should be like easy. Square root of 1. 1. What's the square root of 25? 5. So this now becomes 5 times 1 over 5. Well, these is just multiplying fractions. You know how it's like 5 over 1? 5 over 1 times 1/5. Cross canceling, remember? These 5s go into each other. I could also say it's 5/5. But either way, the answer is 1. So, this whole packet is a bunch of practice. I'm going to do a lot of random ones. I'm going to keep the video going because there's some on page 2 that I want to do. There's some on page 3 that I want to do. There's some on page 4 that I want to do. If you want to ignore me and just go, work ahead, great, you do that. But I'm going to do some that we haven't done yet. We didn't do 27. Number 7. What's the perfect square in 27? 4, 9, 16. 9. Square root of 9 times 3. Remember, you put the perfect square first. Don't put 3 times 9. No, 9 goes first because it's the perfect square. 9 comes out as square root of 9. 3. Aw, poor that 3 inside. I can't touch it. Can't do anything. It stays rad 3. None of these are really that hard. I mean, you just have to know your times tables, right? Some of them are perfect squares, like number 8. Oh, the square root of 64. It's a perfect square. It's 8. I want to do something. Yeah.
Wait, this is all homework?
Yeah. Uh-huh. I want to turn the page. I want to do some on this page. Like number 14. Woo! 125. 4, 9, 16, 25, 36, 25. How many 25s? 25, 50, 75, 100, 125. So on number 14, you're going to do the square root of 25 times 5. By the way, you need to show this work, unless it's a perfect square. 25 is a perfect square. It comes out 5 rad 5 is the answer. On 16, it already has a number in front. So I just do 45. 45. 4, 9, 16, 25. 9 times 5. Okay. The 9 is the only number that's a perfect square. The 4 stays out in front. This 9 is going to come out. What's the square root of... Hold on. You're answering everything. Other people. What's the square root of 9? 3. So, the 4 stays out there. A 3 comes out. And then the rad 5 stays under. It's not 43. It's 12. 12 rad 5. I'll do 17. 5 times rad 20. 20 is 4 times 5. Square root of 4 comes out. So the 5 stays outside. Now I have a 2 outside also. Because the square root of 4 is 2. But still inside, I have the rad 5. 5 times 2 becomes 10. Root 5. I'll do 18. 2 times, it's already a perfect square. Yay! 2 times 10. The answer is 20.
So those types of problems, would it be the same for number 19? Would it be 3 times 10?
3 times 10. 30.
And then for number 21 as well?
21. 4 times 6. 24. Um, 23. They're both perfect squares. So I can split them up, but if you already know they're perfect squares, you can just write 4/5.
Miss Grant,
Yep.
if it's an improper fraction, you have to make it to a mixed number,
No.
like 24.
24, you just leave 12. Oh, 12 over 3.
Yeah.
You can reduce it though,
So we,
because 3 goes in perfect to it. So I'll just make it 4. Look at all these problems I'm doing for you. Let's get it done, right? 25. The square root of 13 is nothing. But what's the square root of 121? 11. So that's fine. Yup. Square root of 24 is 4 times 6 over, well, the square root of 49 is just 7. In my numerator, the square root of 4 is a perfect square. So that's going to be 2 comes out. The rad 6 is still there. 7 stays in the denominator. If I could have reduced 2 over 7, I would have, but I can't. But sometimes you can reduce like that. All right, I'm going to stop the